All right, guys, we're going to go ahead and get started on today's webinar. First and foremost, thank you all so much for being here. As you all probably know, today's webinar is Beyond Eye Tracking. I will be your host today. My name is Emily Boland. I work for a company called Control Bionics. Control Bionics is based in Milford, Ohio, just outside of Cincinnati. And at Control Bionics, we absolutely have the utmost respect and value the joy of communication, which is why we've created the speech generating device we call the NeuroSwitch. This device uses EMG technology to allow those living with ALS, cerebral palsy, spinal cord injury, spinal muscular atrophy, and other conditions to never lose the ability to communicate. I'm going to let our speaker dig into all the details, so let me introduce him. Hannibal Bray is joining us from Washington, D.C. He's the Director of Sales for Control Bionics. Hannibal, are you there?
Yes, Emily, I'm delighted to be here today.
Excellent. Now, you joined us at Control Bionics last summer, correct?
That's right, in July 2014, so I've been here about 8 months now.
And what were you doing before you were taking over sales for us?
Well, I have 10 years of experience in very high-tech medical device sales, and prior to that, I served 8 years in the United States Army as a helicopter pilot.
Wow. So you're a military veteran. Tell me why that was important in your decision to join our team here at Control Bionics.
Well, besides being completely blown away, there were two things that really struck me. One, I had no idea how awful a disease ALS is, and I was just floored when I started to see how devastating the condition can be, not just for the patients, but for the family, the friends, and the caregivers too. And two, when I learned that veterans are 50 to 60% more likely to develop ALS, that was it for me. Knowing that I could make a difference by helping get this technology out there to people who can benefit from it the most, I had to get involved with this team.
That's great. Thanks for sharing that, Hannibal. I think that we all here at Control Bionics, and I'm sure all of our attendees, share your passion for helping all of these people with ALS, not just veterans, not even just those people with ALS, but anyone living with any sort of paralysis or fighting the loss of speech. So first and foremost, to all of our attendees, we're going to be hosting a Q&A segment after Hannibal has finished his presentation. If you have any questions at all that you would like to ask, you can message me directly, Emily Boland, at any time in GoToMeeting, and we'll get back to them at the end of the presentation. So I'm going to go ahead and hand this over to Hannibal to begin.
Thanks, Emily. The presentation portion of our webinar is going to take about 30 minutes, and we have three objectives for you. First, to demonstrate how people with ALS, cerebral palsy, motor neuron disease, spinal cord injuries, and other conditions can use the signals sent by their brains to their muscles to communicate. Two, to illustrate where eye tracking technology may fall short and how EMG can provide a better experience with less hassle. And finally, to empower caregivers and clinicians with information so they can share the latest in assistive communication technology with their patients. To get started, I really like the way that on their blog, A Life Story Foundation breaks AAC down into 4 categories. And I just want to put things into context here. The first, low tech or rapid access, the letter boards, picture boards, head pointers, and lasers, great. Very basic systems. That's not going to be what we talk about today. We're also not going to talk about the medium or mid-tech, the apps, tablets that you can get for your smartphone or computer, the simple, inexpensive switches. What we're really going to focus on today is the high-tech, the custom speech-generating devices that allow you to fully access a computer system and environmental controls. In the future, we hope to be talking to you about a 4th category, wearables, which we really see as being the next generation, including things like heads-up visual display that can be controlled by neural inputs like electromyography. Here's some more from the A Life Story Foundation on the need for early implementation of assistive technology. Now, the rate at which speech may decline with ALS in particular is unpredictable. We don't know if it will be mild, moderate, or severe, or if the onset will be rapid or gradual. Additionally, the process to obtain a device can be lengthy. We also believe that you should learn to use your device before you need it in a stress-free environment. Finally, starting the Medicare 13-month clock ticking may allow you to get your device early. Okay, we're going to spend a little extra time on this slide. As an aviator, I understand and have a passion for user interface. Approximately 200 of the 1,000 or so hours I have in the cockpit flying helicopters were under night vision goggles, at night, or in bad weather, so I understand eye fatigue. Our eyes were naturally designed for the passive act of reading and scanning our surroundings, not operating a computer. So using the eyes in this way causes fatigue and can be more difficult on days when you're tired. So there's some functional issues that we need to be aware of, as well as some issues that pertain to specific conditions. First one we'll talk about is the eye, and being able to move the eyes around is essential for eye tracking to work. So if you have trouble with that, an eye tracking or eye gaze system may not be the best solution for you. There's a couple of conditions we'll talk about. Nystagmus, where the eyes make repetitive, uncontrolled movements, can result in reduced vision with the eyes bouncing up and down, especially at the edges. For those with a cross-eyed condition or a lazy eye, they may require a patch over one of the eyes, and they might be able to use an eye tracking system, but they may have to keep changing eyes because the primary eye gets tired. And this, of course, will require calibration each time they change. If you can't move up and down and or side to side, there can be issues. You need to be able to do both, move up and down and side to side for an eye tracking system to work. You need that volitional eye control, not just visual pursuit where you track or follow a finger up and down or side to side. Finding the center of your pupil is also key for calibration. If you don't have a round pupil, this can be an issue. There's also a condition called ptosis, or drooping of the upper eyelid. Now your eye may only droop slightly, or it may cover the pupil entirely. This can be common in ALS and with people who've had strokes. If you can't lift the lid or it droops too much that you can't get to the center of the pupil, you won't be able to use an eye tracking system. And of course, any general issue with your eyes. If you wear glasses, especially trifocals or bifocals, or just have difficulty concentrating with your eyes, you may encounter difficulty with an eye tracking system. Next is light, and changing light is absolutely the biggest problem for folks who are trying to use an eye tracking system. And why is this? Because changes in light require calibration. So if you're moving around, it can be tricky, especially if you want to go outdoors. And if you're inside, you have to keep the lights turned down, which of course makes it harder for everyone else in the room and harder for you to see anything else besides the screen. There's also, with the changes in the light, you can have mydriasis, or dilated pupils can be a problem. And this is also a side effect of baclofen, one of the muscle relaxers that's often given to people with ALS and other conditions. So again, this will make connecting to your eye tracking system difficult because eye tracking relies on the corneal reflection from the center of your pupil. And finally, the third functional issue we'll talk about is positioning. These eye tracking systems depend on you being a fixed distance from the screen. So if you're moving around, it's going to require constant calibration. Now let's talk about some of the specific conditions. And the first one we'll talk about is ALS. And most people with ALS develop dry eyes because they're blinking less often as their eyelids start to slow down as a result of the motor neurons failing. And light doesn't reflect well on dry eyes. So this low moisture for people with ALS due to a lack of tears means the eye surface is often not smooth, because any tears or moisture that the patient does have sticks to the surface of their eyes like glue because they're not blinking enough. So they need eye drops. And if you go without drops for more than a couple of days, it can lead to corneal abrasions, which are not only really uncomfortable, they also cause scarring. And once you get scarring, you won't be able to use an eye tracking system. Oh, and using an eye tracking system can also make your eyes even drier. As the motor neurons start to slow down, the eyes can get frozen in place where you can't use an eye tracking system. The third we talked a little bit about is mydriasis, or the dilated pupils from drugs like baclofen, and also ptosis, the drooping of the lids. So the next condition, brain injuries, and including stroke, this depends on which nerves have been affected, and it can be a difficult puzzle to figure out, as the cranial nerves, which affect your eyes, are often affected by the injury. Now, brainstem injury usually causes locked-in syndrome, and this may affect the eyes, as the optic nerves are in the same area. Sometimes this results in double vision and or a slow and unresponsive eye movement. The next condition, cerebral palsy, we'll see similar issues as we do with the brain injuries, and it's common that the eyes won't work together. CP is also characterized by spastic movement, which makes focusing difficult, and the concept of moving your eyes independently without moving your body can be a foreign concept to most people with CP, and is just impossible for them to do sometimes. The next condition is multiple sclerosis, and folks with MS will often take steroids, and that can cause cataracts, which will impair their ability to use eye tracking system. So let's summarize. Do you want to have to pick between watching TV, looking at the people who are in the room with you, or communicating? We don't think you should have to. Remember, your eye tracking system will need calibration whenever the light changes. So if you like sitting outside in the sun and being able to communicate at the same time, expect some challenges. You'll need to make sure your caregivers are trained to help you manage this. We discussed the functional issues some people have with their eyes and how some of those issues are exacerbated by specific conditions like ALS, brain injuries, stroke, CP, multiple sclerosis. And of course, the biggest challenge with the ventilator is that it aggravates the situation by drying out the eyes. The eye's hydration is radically changed when you're on a ventilator. Now, for some people, eye gaze or eye tracking systems will work just fine. But at Control Bionics, we get those calls and emails from the people it simply doesn't work for, or who it no longer works for. So our purpose today is to educate you on an alternative, the NeuroSwitch, because it may be a better solution for some people right from the start. All I know is that when I spend several hours in front of my computer staring at the screen, sometimes it starts to look like this. My eyes get tired, and I have trouble focusing. So some of the advantages of the NeuroSwitch that you're going to learn about are signal, regardless of positioning or the ambient light conditions. Calibration is automatic. You can stay online all the time. And what our clients tell us after using the NeuroSwitch for a short period of time is that they feel as though they become the switch. Your performance won't be hindered by any eyesight or oculomotor issues. And your family and caregivers will need very minimal training to get started. Further, we'll support them 24 hours a day, 7 days a week, 365 days a year. And the bottom line is that with EMG-powered communication, there's less fatigue, and it adapts to your energy levels on any given day. So if your signal is weaker, the NeuroSwitch adjusts and continues to work. So this is the NeuroSwitch, EMG-powered communication. It's safe, it's clinically proven. We're registered with the FDA for powered communication and environmental control. And we've also worked closely with the veteran, specifically to help veterans who are twice as likely to develop ALS. Now, they say that seeing is believing, but with the NeuroSwitch, the feeling is believing. And one of the hardest things to convey here is the feeling of using it. Now, it's impossible to explain the magic of the NeuroSwitch, but let me just tell you what happened the first time I met Peter Ford, our founder and CEO. Last June, I showed up at the Army-Navy Club in Washington, D.C. for the job interview, and Peter says, "G'day, mate, take off your jacket," which I thought was a little odd, especially since the Army-Navy Club has a strict coat and tie policy. Anyway, to make a long story short, within 5 minutes, Peter had me roll up my sleeve. He placed a simple adhesive sensor on my arm, flipped a switch on a little blue box, and voila, I was talking through a computer.
Hello, how are you?
And then he showed me how to play music on iTunes. surf the web, and some other cool features we'll get to in a minute. But the hardest part of using the NeuroSwitch for me was to just sit back and relax because I was so excited by what he had me doing. It was like 20 years ago for me on that first day of flight school, sitting in the cockpit of a Huey helicopter, trying to wrap my head around the fact that such small movements, motor movements in my fingers, could have such a profound impact on the main rotor blade whirling above me. So how does this work? Every time the NeuroSwitch detects a signal in your muscle, it transmits that signal wirelessly via Bluetooth to a MacBook Air laptop computer, which is included with the system. Next, you make selections using scanning technology. The software we use from Assistive displays an initial menu on the screen, which you'll see here in a minute, and we have many on-screen menus or keyboards that you can choose from, and we can even create custom keyboards as well for each user. The software then goes through and highlights each of these options row by row and then column by column. So it will go from top to bottom until it gets to the row that you want to select. By making a second signal, the tracking or the scan will then move in groups from left to right. Now, the nice thing is that if you miss it the first time around, it'll go through a second time. After it goes through the second time, the default setting is it will time out and it will stop. And to initiate the scanning sequence, you just start over. You create one signal switch, and it'll begin tracking again from top to bottom. Now, this is totally customizable for each user. We can change the speed at how fast it scans. We can change how many times it goes through the scanning sequence. And this is totally adaptable as a controller gets more comfortable with their system. For speech generation, you can type out the words letter by letter, or we'll show you how to use the predictive text to get leverage and type more efficiently. You can also select your favorites, and we can program in buttons that for specific phrases and also to take you to your favorite websites or other features like iTunes. Now, this description of scanning will make more sense in just a moment when we show you a short video. So what you're about to see here is a 2.5-minute video of the NeuroSwitch in action, where we'll demonstrate some of the most popular features, like playing music, selecting preset words and phrases, smart typing with predictive text, speech generation, surfing the web, and shortcuts to other favorite functions. Now, the first feature you'll see and hear is the music playing through iTunes, and the sound quality will suffer a bit coming through this webinar, but you'll get the idea. About 30 seconds in, the music will stop, and you'll be able to hear me narrate the rest of the functions we're exploring. If you've never seen scanning before, this may be a little overwhelming, but don't worry. We'll break this all down into smaller chunks after the video.
Bring up iTunes. Loading home panel. Bring up Prolic Bow. Bring up keystrokes protection window. Hello, how are you?
So here I just used the hello button to type that phrase.
Thank you.
And there's another example with the thank you. And again, any phrase that you want, we'll show you how this can be programmed in there. Now I'm going to demonstrate the predictive text. I type the letter T and look over on the right. Number 10 is the word time. So if I select the blue number 10 in the top row, it finishes that word for me. Let's try that again. Now I'm going to type the letter F. And I want to select the word for. So the blue number 1 in the top row. And let's type one more word. So So the word I'm looking for is not in the predictive text, so I'll just keep typing. And the nice thing about the predictive text is it will adapt with you. It will get smarter. If there are certain words that you use more frequently, they will rise to the top of your selection.
Hello, how are you? Thank you. Time for fun. Loading utilities controls.
So by pressing the red Swiss Army knife, it takes us to another panel here
Launching Facebook.
where we can explore some of the other favorite options. And in this case, we're going to go to Facebook. And you'll notice that the keyboard has disappeared through a feature called Smart Transparency. So you have an unobstructed view of what you want to see on the website until you're ready to navigate down. On this board here, you can see the up, down, left, right, and diagonal arrows. The blue arrows, those are used to control the mouse. You can also do single, double clicks, right click, enter, and probably the two most useful buttons for browsing the web on Facebook are the page up and page down button. Now, for a person who's not very comfortable with computers, we can offer a very simple keyboard with just a few choices covering the fundamentals. What we found is that even these simple choices can be a huge leap forward in quality of life. Notice that each of these buttons navigate toward another custom panel that is personalized for each user. And on the top right of every keyboard panel is a red home button to get back to the main keyboard. As the NeuroSwitch user, or we call them controllers, as they become more comfortable with their system, we can add more customized keyboards just for them. Like this keyboard with additional greetings and common phrases. When I first met Mike Phillips in Tampa, Florida, I walked into his room and I was just blown away. I knew that he was a Nirvana fan, and we talked a little bit about Kurt Cobain and reading his journals. And within just a couple of seconds, he was blasting me out with the speakers in the room. He uses his NeuroSwitch to do so much, and I'm going to show you a video here in a minute that shows you what he's capable of. Mike is an Apple super user, and he's one of the reasons that we currently operate on the Macintosh platform. One of the things we've learned from working with controllers like Mike is the value of remote telepresence and being able to come online for support sessions and perform troubleshooting and free software upgrades from time to time. The Apple platform has just proven to be much more stable for us and less susceptible to things like malware. So here in Mike's room, I just want to point out a couple of things. On his forehead there, above his right eye, that's the actual sensors that are hooked up to the NeuroSwitch. And if you look closely in the video, it moves kind of fast. You'll see him wiggling his forehead to create the signals. Also, I want you to see the flat panel monitor over the bed that's angled just for him, and it's mirrored. It's used the mirror display via Apple TV. Now, Mike scans at 9 times a second, so in this next video here, if you blink, you might miss some of it. So watch for it on the left side of your screen. It'll be in light purple color and moving very, very fast. And remember, everything you'll see Mike do in this video, he's controlling just by raising his eyebrows. So there you see it moving on the left, very fast, with just a slight wiggle of the forehead. His blog, updating his calendar. And Mike edited this entire video. One of the other videos that we'll be showing you soon in the future, we'll post up on our blog. Mike actually helped us get involved in the Ice Bucket Challenge, and he conducted his challenge by driving a telepresence robot in California. And he did all this from Tampa, Florida. We look forward to showing that to you soon. Mike has a condition called spinal muscular atrophy and has been using NeuroSwitch for the last several years, and is clearly one of the most advanced users we've ever seen, and we've learned a lot from working from him. This next video is kind of the other end of the spectrum. This is a person with ALS, and this is from about a month and a half ago, and this was after 1 hour of using the NeuroSwitch, and we rigged this up with a sensor on the leg because his right foot, he had some good volitional control there. He was using it to type or he's using it to spell out words with his big toe. And with just a little bit of practice, here you can see him scanning just at a basic rate of 1 per second. But he's typing out words letter by letter. He was using the predictive text. We got him playing the music. We got him to activate that alarm in the upper left-hand corner. He had a great first experience with it. And you can't quite see it, but behind the screen there, he does have an eye gaze system over there collecting dust in the corner that he was no longer able to use when we got in touch with him. And what was really satisfying for us was about a month later when the Veterans Administration purchased the NeuroSwitch from him as he is a Navy veteran, and this is during our first live telepresence session. You can see there's me down on the bottom right. I'm in Washington, D.C. On the left there, that's Peter Ford. He was doing this from Sydney, Australia. And our controller is coming to us from Virginia Beach. And the first thing he typed out is "This is wonderful." So just demonstrating the value of 24/7, 365 days support. No matter where you live, we look forward to being a part of the communications team for you or your family or your patients that you may put us in touch with. So let's talk about the NeuroSwitch a little bit more. NeuroSwitch is non-invasive, and we emphasize this because particularly many people with ALS have had a very uncomfortable procedure called an EMG test during their diagnosis. And while this is the same EMG technology, it's different. The NeuroSwitch, it's completely painless. Our users control the NeuroSwitch through adhesive sensors that sit on their skin. In this example, we're tapping into the flexor carpi ulnaris muscle on the inside of the left forearm, and we attach 3 leads. The first 2 are detection leads. They're the ones in white that are placed longitudinally along the muscle. The black lead is for reference. It's offset, and it filters out any of the background noise so we can get a nice, clean signal. And this is what that signal looks like on the computer. You'll see a waveform, and you can see a couple of controls there. We can change the switching speed from 1 per second all the way up to 14 switches per second. And remember, in the video I showed you with Mike, he was switching at about 9 per second. The threshold is set currently at 50 microvolts. Again, a microvolt is a millionth of a volt, and we can dial this all the way down to 1 or take it up as high as we need to help fine-tune, and this is helpful if we're trying to adjust for conditions like spasticity, fasciculation, and athetosis. And these leads detect the signals from the brain sent to the muscle. And the NeuroSwitch, because it uses the body's own electrical system that's generated inside the muscles. And what's amazing is that even when a muscle is paralyzed, we can almost always detect a signal somewhere upstream with the NeuroSwitch. These are some of the other access sites that we can use to harness that signal on the forehead, on the arm, the quadriceps, or on the leg, like you saw with the previous controller. But with the NeuroSwitch, it really puts you in control because it's smart enough to recognize and filter out those muscle twitches, spasticity, or any of those unintentional movements. The leads detect the electrical signals that you are sending from your muscle to your brain, so only your intentional movements are interpreted as signals. And with the NeuroSwitch, you're in control, which can be incredibly empowering. So to recap some of the features of the NeuroSwitch, it's reliable and durable. It's fast because your body's electrical system is fast, as well as the NeuroSwitch processors. Even when you're tired, it's incredibly sensitive. And what our controllers tell us is that after a short period of time, they feel as though they become the switch, and it's just effortless to use. The sensors can be moved as necessary. If we start with an access site on the leg and need to move to the arm or the forehead, there's no new learning curve. It's just a new access point. So it can really be personalized for each controller. making it a switch that will work for the duration. As we wrap up here, I just want to show you a couple of testimonials from our controllers. This is Glenn Sargood in Australia, who's really gotten back independence and freedom. Gary Griffin was an Air Force veteran in Nebraska, and I just want to qualify this. We're not making any claims saying that the NeuroSwitch will necessarily be 3 times faster than what someone else might be using, but for Gary, what Chad witnessed after all the trials and devices that he tried, it was definitely the thing that he rocked on the most and made a huge difference for him. And Gary's wife Lisa had this to say. The impact it had not just for him, but for everyone else who was involved in his care and his life. As we wrap up here, I want to leave you with a couple other resources, and Emily is going to put these URL addresses in the chat box for you to do some research. If you're involved in the ALS community, you're probably already familiar with the great work that ALS TDI does, and it's a great way to stay up to date on the latest and greatest with therapy and trials. I also want to highlight our friend Jay Smith at Every 90 Minutes and the work that he's doing for awareness and fundraising, helping people tell their story for people with ALS. Definitely a warrior and a brilliant marketer. Always follow him on the social media on Facebook. And of course, the ALS Association. Specifically, I want to highlight the Greater Philadelphia chapter. I was able to attend an event last week hosted by the Greater Philadelphia chapter, and I'm just thoroughly impressed by everything they're doing in person with their outreach, their fundraising, and education as well. They've recently launched a podcast series over the last couple of months, and it's definitely worth going back into the archives and going through those podcasts. The most recent one specifically dives into assistive technology. Kevin Swan at A Life Story Foundation, you'll notice we borrowed some of the information from one of the blog posts there in the opening slides talking about AAC and the need for early implementation. This is a great site for people to tell their story and learn more about ALS. And we've been talking a lot about ALS, but I want to make sure it's clear that the NeuroSwitch is not just for ALS. We also are working very closely with the Cerebral Palsy Alliance in Australia, and we continue to look for more applications, and it really just becomes a very personal thing, whether when someone calls us and wants to know and they describe their condition, will the NeuroSwitch work for me? Will it work for my husband or my son or my daughter or my friend? And the only way that we'll know that is through a one-on-one assessment, and we'll talk a little bit about the way to do that, but it's really just as simple as going to our website, reaching out, giving us some contact information, telling us your story. We'll get back in touch with you within 24 hours, and we can get that dialogue going to see if it might be a good fit for you or not. So that concludes the formal presentation part of this webinar. Emily, I'm going to turn this back over to you and see if we've got any questions that have been coming in.
Yes, thank you, Hannibal. Thanks for all of that valuable information. We have collected a few questions throughout the presentation. So as Hannibal said, we're going to start the Q&A segment. Any of our listeners, if you would like to submit a question to Hannibal, you can message me, Emily Boland, directly in the GoToMeeting chat window. So our first question is actually related to what you were just talking about. Someone would like to know, is the NeuroSwitch a good candidate for a patient with cerebral palsy? Do those spastic movements you previously mentioned that are sometimes present in cerebral palsy patients interfere with the EMG signal?
That's a great question, and when we talk about spasticity, you're absolutely right. It can be a challenge. So the two primary things that we can dial in is the number of signals that the NeuroSwitch detects. So remember, there's 3 sensors that go on the arm or the leg or the forehead or the leg, and if the muscle is moving uncontrollably, or if there are more signals being created than we want, we can dial it down so that it only reads 1 per second. Sometimes that will work. The other thing we can do is increase the threshold. In the example you saw, we had it set at 50 microvolts, which it can be very easy to create that signal just by wiggling a finger or raising an eyebrow. But in the case of CP, like you mentioned, 50 microvolts, you might be getting signals all over the place that you don't intend to. So in that situation, we can increase the threshold to 100, 200, or even 300 microvolts or higher, and that can be very helpful. That's how we adjust for that.
So we have another related question. What about a child that doesn't have any visible muscle movement, a child or adult where no muscle contractions are actually visible? Does the sensor work for that child or adult?
Now that would be something we would have to look at one-on-one on a case-by-case basis, and what we would we would love to talk to you further. And one of the best ways that it can be helpful for us is if you can either send us a video of if there's any movement at all. I know you're saying there really isn't any, or even a Skype webcam where we can kind of get a look at the situation. And we'd love to know more about what, if anything you're using right now for assistive technology or communication. And without knowing more, it's hard to really say. But what surprised, the amazing thing for me that I see time and time again is that even if the muscle doesn't move, there's oftentimes still a signal there. We can almost always tap into it. And I don't want to say for sure until we actually try it. But it's really hard to describe until you see that. Now, if there is volitional muscle control, if we can see the muscle move under your own voluntary control, then we almost certainly know that it will work. If the muscle's not visibly moving, oftentimes it still will. A lot of the times it still will, but we just won't know for sure until we try.
Great. We have one more question. Actually, we got a few more just now. Has anyone looked into the possibility of using the NeuroSwitch with the switch scanning feature of the iPad?
So that's a great question. We have not rigged this up specifically to work with the iPad, but a lot of folks ask us that, and folks who can still use an iPad, that may be a great option for them. What we're actually working on is taking this hopefully a quantum leap beyond that with some of the things we talked about in the first slides on wearable technology and things like heads-up display. However, right now it runs strictly on Apple MacBook Pro, which again comes included with the system.
Great. So how long does the NeuroSwitch last? If someone purchases one, will it become outdated, and does the controller or caregiver have to pay for the upgrades?
Great question. NeuroSwitch is very, very durable, and the software comes with lifetime free upgrades on the software. That's all covered. The hardware, if you want any upgrades, those are at cost. So say, for example, after 3 or 4 years, if Apple comes out with a new version of the MacBook and you want that, whatever it is at cost, we'll upgrade that for you. You purchase the hardware, and we'll transfer the software and get you all set up at no additional cost.
Great. So what is the actual process? How does someone go about getting a device?
So there's a couple ways to move forward, and on our website there's a link called Purchasing. There's documents on there that can be downloaded with price sheets, parts lists, and it describes the assessment process, but it basically falls into 2 categories. We can do an on-site, in-person assessment where one of us comes out to your home, a chance to try the NeuroSwitch for a couple hours, and we'll know within the first 5 or 10 minutes if it's something that will work. We'll know that if it's going to be efficacious for you. It may take you a while to decide if this is something you want to invest your time into learning, to invest your money in purchasing, but typically folks know right away if it's something they want to pursue. That process, we charge a fee of $1,200 to come out for an on-site assessment, and if someone ends up purchasing the NeuroSwitch, then that comes off of the final purchase price. The other way to go is a remote assessment for $250 to cover our shipping and insurance. We will send out a device and we'll let you keep it overnight. We'll let you try it, and what we do is we come online with you via telepresence using either GoToMeeting like we are right now, or we'll use Skype where we can come online and turn on the webcam so we can get a good look at your situation, and we can demonstrate how to place the sensors, and we'll be able to share screens. We'll be able to see everything you see on your screen. We'll be able to talk you through that process. Those are the two primary ways that folks get initiated with the process.
So a couple more. Can one NeuroSwitch be used with multiple computers? And how long does the battery last? How is it charged? The actual NeuroSwitch device, not the MacBook.
Great. Let me take the battery one first. It's 5 hours. So the NeuroSwitch comes with 2 rechargeable lithium-ion batteries. They've got gold plating on them, so the connection plates prongs are made of gold, and it comes with 2 of those. They last for 5 hours, and it comes with a wall charger. So while you're using one NeuroSwitch, you can always have the other battery charging. And those batteries tend to last for a couple of years. The replacement on them each if you ever need additional batteries. And the second half of the question, I'm sorry, Emily, remind me that.
Can you use it on multiple screens?
Oh, of course. So the NeuroSwitch comes standard with a 13-inch MacBook Air laptop. However, we've had some controllers who wanted a larger screen. They wanted the 15-inch MacBook Pro with Retina display, and they can purchase that right from the get-go for an upgraded hardware fee, basically at our cost. Or they can add that as an additional computer, or some actually have asked for the smaller version, the 11-inch MacBook Air. So they got the standard 13-inch, and then they wanted an extra computer to go with it. And we can absolutely set up the licensing and do the installation so that you can use your NeuroSwitch on that second computer that we set up for you.
Great. Do caregivers need to be tech savvy to maintain the NeuroSwitch on a daily basis for the controller?
That's a great question, and that's really one of the fundamental highlights of the NeuroSwitch is that no, you don't. All your caregiver needs to be able to do is pick up the phone and give us a call. We'll give you a local number where you can reach us 24 hours a day, 7 days a week, 365 days a year. If we can't deal with it in immediate real time, we will get back to you very quickly to help get you back online, to troubleshoot any problems, any emergencies that may come up. That's also how we come online to do the software upgrades. And we expect you to give us a call. Our service and support is really a concierge service that we expect you to push us, especially during the first several weeks. If you're not calling us, we're going to be calling you, just to make sure that you're getting everything out of your NeuroSwitch that you want, and to make sure that you're not having any issues. So you don't have to make an appointment. You don't have to transport into an office or a clinic somewhere. You don't have to wait for a rep to come out. We can do this in real time and get you back online in short order.
Great. We're going to take one more question. Can the device be mounted to a wheelchair as tablets can? Is there the possibility of the device controlling a wheelchair?
Great question. Let me handle the mounts first. Yes, absolutely, it can be mounted to a wheelchair. The 13-inch MacBook Pro weighs, I think, about 2.5 pounds. If you get the larger one, it's a little bit heavier. You might need a little bit sturdier mount, but for folks who are interested in pursuing that, just contact us directly on the website, and we'll reply back with a couple of different companies. We don't particularly endorse one company or the other, but there are several companies out there that make very high-end mounts, some very simple mounts that you can mount to your chair, as well as ones with full articulation and hydraulics, and you can really just get as fancy as you want with those mounts. But we can provide that information to you directly based on your type of chair, because it really gets into the specifics of what type of chair you have. We work with a couple of companies who are great at that. And again, Emily, what was the second part of the question?
Is there the possibility of the device being used to control a wheelchair?
Oh, absolutely. We actually have a video of one gentleman who's already done this, who's used the NeuroSwitch to control his wheelchair. This was a one-off situation, and it's not a commercially available application yet that we have, but the technology is definitely there, and it's something that we'll continue to beta test and get that ready for prime time.
Great. Well, we're going to go ahead and wrap up the Q&A segment of this webinar. Thank you guys all for all the great questions. I'm sure there were a couple that we didn't get to. If you guys have any further questions, you can reach us at our website. It's www.controlbionics.com. You can also reach us through our Facebook and our Twitter page. In case you missed anything today or you want to share any of the information you've learned, we'll be posting this webinar through our website on our blog, again, at controlbionics.com. And if you would like to reach out to Hannibal directly, you can email him at hrbray, B-R-A-Y, at controlbionics.com. Thanks again, Hannibal, for all your time.
Thank you, Emily. It was a pleasure to be here.
Yes. Thanks to all our attendees as well.